Saturn's rings are home to a dazzling array of moons, each with its own story, but few are as instantly recognizable as Mimas. This small, icy world orbits quietly among Saturn's majestic rings, yet it has captured the imagination of scientists and sci-fi fans alike. When Voyager first sent back images in the 1980s, Mimas's uncanny resemblance to the Death Star from Star Wars made it a pop culture icon overnight. The comparison was impossible to ignore, and soon, Mimas was known as the Death Star moon. The reason for this striking similarity? A colossal impact crater, known as Herschel, dominates one side of Mimas, complete with a central peak that looks remarkably like the super laser dish from the movies. But this isn't just a fun coincidence. It's a clue to Mimas's violent past. The Herschel crater is over 130 kilometers wide, nearly a third of the moon's entire diameter, and its formation nearly shattered Mimas apart. For billions of years, Mimas has been battered by impacts, its surface a frozen record of the early solar system's chaos. Each crater tells a story of collisions with asteroids and comets, painting a picture of a turbulent era long past. For decades, scientists thought Mimas was geologically dead. No geysers, no shifting plates, just a static ball of ice and rock, locked in time and silence. It seemed overshadowed by Saturn's more active moons, like Enceladus with its dramatic geysers, or Titan with its thick atmosphere and methane lakes. But science thrives on surprises, and the universe is full of them. Just when we think we have a world figured out, new discoveries force us to rethink everything. New data has revealed that Mimas may be hiding something extraordinary beneath its battered surface. Subtle wobbles in its orbit and hints from spacecraft flybys have raised tantalizing questions. Recent studies suggest that, under its ancient crust, Mimas could conceal a global ocean of liquid water. If true, this would make Mimas a potential haven for life, and a key to understanding icy worlds. This possibility has transformed Mimas from a relic into a prime target in the search for habitable worlds. Suddenly, a moon once thought lifeless is at the forefront of planetary science. Suddenly, the Death Star moon isn't just a curiosity, it's a mystery waiting to be solved. A world with secrets locked beneath its icy shell. What secrets could be lurking beneath that icy shell? Could there be hydrothermal vents, or even the building blocks of life? Mimas, once dismissed, is now one of the most intriguing objects in the solar system. Its story is still being written, and every new discovery brings more questions. The hunt for answers has only just begun, and the next chapter in Mimas's story could change our understanding of the solar system forever. The defining feature of Mimas is Herschel crater, a colossal impact site that dominates the moon's battered surface and instantly draws the eye of anyone who studies this distant world. The crater is named after William Herschel, the astronomer who first discovered Mimas in 1789, forever linking his name to this remarkable moon. Herschel is enormous, about 139 kilometers across, nearly a third of Mimas's diameter. Its sheer scale is almost unimaginable, especially when you consider the moon itself is only about 396 kilometers wide. If Earth had a crater that size, it would span the width of Australia, stretching from coast to coast and reshaping the entire continent. The impact that formed Herschel nearly shattered Mimas, sending shockwaves through its icy core. Yet, the moon survived, leaving behind steep crater walls and a towering central peak that rises from the center like a frozen monument. This peak, formed by the ground rebounding after the impact, offers clues about the moon's icy crust and the forces that shaped it. Its jagged, icy textures tell a story of ancient violence and resilience. By counting smaller craters inside Herschel, scientists estimate it formed around 4 billion years ago, during the solar system's violent late heavy bombardment, a time when impacts were frequent and catastrophic. Herschel is a frozen scar, a testament to Mimas's resilience and the incredible forces that shaped the early solar system. For years, its existence was seen as proof that Mimas was a dead world. Any heat from the impact should have long since dissipated, leaving only a cold, silent shell behind. The moon's small size meant it should have lost its internal warmth eons ago, unable to hold on to the energy needed for geological activity. The cratered, unchanging surface seemed to confirm this, with no signs of recent activity or change for billions of years. But recent discoveries have upended that view, hinting at mysteries beneath the surface that scientists are only beginning to unravel. Herschel is no longer just a relic of ancient violence. It's a window into the moon's hidden depths, and perhaps its surprising potential for activity. The story of Mimas is far from over. As we continue to explore, each new discovery challenges what we thought we knew. The crater that made Mimas famous may also hold the key to its greatest secret, one that could change our understanding of icy moons forever. The first hint that Mimas was more than a frozen relic came from a subtle wobble in its rotation. Using data from the Cassini spacecraft, scientists noticed Mimas's libration, its wobble, was twice as large as expected. This suggested something unusual inside the moon. Two theories emerged. Either Mimas has a bizarre, elongated core, or there's a global ocean beneath its icy shell. The ocean theory was especially intriguing. A liquid layer would allow the outer shell to move independently, matching the observed wobble. Suddenly, the idea of a hidden ocean became a serious scientific hypothesis, yet Mimas's surface showed no signs of activity, no cracks, no geysers, nothing like other ocean worlds. How could a liquid ocean exist beneath such a cold, ancient surface? The evidence from the wobble was compelling, but indirect. Was it a weird core, or a secret ocean? More evidence was needed to solve the mystery. Mimas had become a puzzle, challenging everything we thought we knew about icy moons. The search for answers was on. If Mimas does have a liquid ocean, what keeps it from freezing solid? The answer lies in tidal heating, energy generated by Saturn's immense gravity. As Mimas orbits Saturn in an elliptical path, it's squeezed and stretched, creating friction and heat inside. This process is like bending a paperclip until it gets warm. For years, scientists thought Mimas was too small to generate enough tidal heat, but the discovery of its large wobble forced a rethink. New models showed that if a liquid ocean exists, tidal heating could be much more efficient. A solid moon flexes less, but a liquid layer allows the shell to move and generate more heat. The ocean itself helps sustain the warmth needed to keep it liquid. Tidal heating and a hidden ocean could form a self-sustaining system. Mimas, once thought frozen and inert, might be far more dynamic beneath the surface. The secret to its warmth could be the very force that binds it to Saturn. If Mimas truly has a subsurface ocean, it joins an exclusive club with Europa and Enceladus, two of the most intriguing moons in our solar system. These worlds have fascinated scientists for years, thanks to their hidden seas beneath thick layers of ice. But unlike those moons, Mimas shows no obvious signs of activity, no geysers, no cracks, just a cratered, frozen surface that seems unchanged for eons. Its appearance is deceptively simple, almost as if it's hiding in plain sight. Enceladus erupts with plumes of water vapor that shoot into space. Europa's surface is laced with cracks and ridges, hinting at the dynamic forces below. These moons wear their oceans on their sleeves, making their internal activity visible to passing spacecraft and telescopes. Mimas, in contrast, is a stealth ocean world, its secrets hidden beneath a thick, rigid ice shell. There are no dramatic plumes or shifting ice plates to give away what lies beneath. This suggests that subsurface oceans can exist without any surface clues at all, challenging our assumptions about where to look for life and liquid water. There could be many more quiet ocean worlds out there, their oceans hidden from view, waiting to be discovered by future missions and new technology. Mimas's ice shell may be 20 to 30 kilometers thick, sealing its ocean away from the vacuum of space and protecting it from prying eyes. Some models suggest the ocean is young, perhaps only a few million years old, so it hasn't yet reshaped the surface or left obvious marks for us to find. Mimas could be a world in transition, its ocean just beginning to make its mark, hinting at future changes that may one day become visible. The lesson? Don't judge a moon by its cover. Even the most unassuming worlds may hold astonishing surprises beneath their icy exteriors. Even the quietest worlds may harbor profound secrets, waiting patiently for us to uncover them. The search for hidden oceans has only just begun, and Mimas reminds us that the universe is full of mysteries yet to be revealed. Why do subsurface oceans excite scientists so much? Because where there's liquid water, there could be life. On Earth, life thrives wherever water exists, even in the darkest, coldest places. Subsurface oceans are shielded from space by thick ice, creating stable, protected environments. If there's energy and the right chemistry, these hidden seas could be cradles for alien life. Hydrothermal vents on Earth's ocean floors support entire ecosystems without sunlight, using chemical energy. Similar vents could exist on moons like Mimas, providing the ingredients for life. The discovery of a possible ocean on Mimas expands our search for habitable worlds. If a quiet, cratered moon can hide an ocean, maybe life is more common than we thought. Every icy moon becomes a potential target in the search for life. Mimas challenges our assumptions and broadens our horizons. The universe may be teeming with hidden possibilities. The evidence for a Mimas ocean is strong but still indirect. Proving it exists is a huge technical challenge. We can't just drill through kilometers of ice. Scientists are developing clever ways to probe the moon's interior from afar. Ice-penetrating radar could reveal a liquid layer by bouncing signals off the ocean boundary. Precise measurements of Mimas's gravity and shape could show how much it flexes under Saturn's pull. Subtle surface clues, tiny cracks or chemical traces, might hint at processes below. Each new observation brings us closer to the truth. The mystery of Mimas's interior is a puzzle for the next generation of explorers. The hunt for proof continues. The possibility of an ocean on Mimas has made it a top target for future missions. Cassini gave us the first clues, but we need new spacecraft with advanced instruments to confirm the ocean. Mission concepts include orbiters with ice-penetrating radar, high-resolution cameras, and gravity experiments. A lander could provide direct measurements, listening for moonquakes or measuring heat flow. Even a flyby from a future mission to the outer solar system could yield valuable data. Every new observation will help unlock Mimas's secrets. The next chapter in the exploration of Saturn's moons is just beginning. Mimas is ready for its close-up. Mimas's story is a lesson in scientific humility. Once dismissed as a dead, uninteresting moon, it's now a prime candidate for a hidden ocean. This discovery forces us to reconsider where habitable environments might exist. If Mimas can have an ocean, so could many other icy worlds. The ingredients for life, water, energy, chemistry, may be far more common than we imagined. Mimas could be the prototype for a new class of stealth ocean worlds. The questions it raises are profound. Is there an ocean? Could it support life? Answering them will require new missions and new ideas. Mimas is a symbol of the surprises our solar system still holds. The little Death Star moon may yet become a beacon of hope in our search for life beyond Earth.